a fundamental section. Why it is a very important section? Because it is about the fundamental theorem of calculus. We will divide the fundamental theorem of calculus into two parts. FTC1, which is shortcut for the fundamental theorem of calculus, and of course FTC2. To understand what they are about, let me start with asking you, in every subject, almost in every subject, there is a fundamental theorem. Do you remember what is the fundamental theorem of, for example, arithmetic, trigonometry, algebra? Let's algebra. What is the fundamental theorem of algebra? I think you have studied this with the same name, the fundamental theorem of algebra. What is it? Just a sharp, I think you have studied it in MATH101, but it looks like you forgot it long time ago. So the fundamental theorem of algebra says that every polynomial of, let's say every equation of polynomials with degree n has a solution, has a solution in the complex numbers system. The fundamental theorem of calculus, anyway, to understand the objectives, what are the objectives of this section? Let me ask you this question at the beginning, if you know it. What is the derivative of the integral? We know now from 5.2 what is the definite integral. This is a kind of definite integral. So what is the derivative of this integral?
F of x.
This will be f of x. You're right. This is f of x, yes, Shabab. So this one, it is just f of x. So the next question, we will generalize this. What about when we have a function? What do you know? Do you know what is it? So this is just a generalization for this. Here we have x, here we have a continuous function of x, and it should be also differentiable. Do you know what is this?
F of x times the differential of v of x.
It is f of
x.
No, it is not f of x. It is f of v. F of v of x times the derivative of v. Thank you. All right. This is called the Shabab, and the more general form of this is this: when you have a function in the lower limit and the function in the upper limit. And who knows what is this also? We will see together, Shabab, what is this. I will delay that part. It's okay. Okay. Now, let me ask you this question now. What is the integral of the derivative? Now here we differentiate here the integral. Here we are differentiating the integral. Here we are integrating the function. Who can knows what is the answer of this?
F of t.
This is f of
t.
F of t. No, it is not f of t. It will be f. This part is good, but this part is not true.
t double prime.
No, it is not f double prime. We will see together, Shabab. So keep it an open question. We will see what is it. And of course, we have also, we can ask ourselves also, what is the integral of a function from a to b? This is the definite integral. How to calculate it? How to know it? What is it? We know from 5.2 that it could be an area f or a net area. So now, ya Shabab, the answer of this question is just the fundamental theorem of calculus part 1. And the answer of these two questions, it is the same, of course, it is the same question. It is the fundamental theorem of calculus part 2. Let's start now with relating what we have today for what we have studied before. Who can, ya Shabab, give me the integral that is corresponding to this area? So we have a region here. If we call the area, x here is a variable. X here, it could be here, it could be here, it could be any number between a and b. So let's say that it is x is here. So it is a variable. Now, because of that, it is a function of x. So the area here is a function of x. It depends on x. So let's call it g of x because it is a function of x. If x is changed, the area will be changed. Now, who can give me what is this in terms of integral? So this is the integral of what? From where to where?
X to A.
This is the integral of, this is, what is the integrand function here?
GX.
The integral of g of
f
x?
of t. F of t.
فات.
The integral of f of t يا شباب, not the integral of the area. The area is the integral from a point to a point for the function that is, what is my graph? My graph is this. So this is the graph that we have the region below this graph. So the integral will be from f of t, the integral of f of t dt طبعا, because this is the variable of the integration. From where to where? From a
To X.
to x. So it is also a function of x. It depends on x. So this is indeed, this is the area. And what is the area? We call it what? We call it g of x because it depends on x. So it is a function of x. And if you remember the last exercise that we have solved in the recitation class, it was about this idea, an idea about having an integral, a definite integral, when the upper limit is a variable. Now this is a function of x. And whatever you will evaluate, do this at the end, it will depend on x. So it is a function of x. So we call it g of x. For example, if you take this one, f of t to be t, so and a also to be 0, just as an example. So this will be the integral from 0 to x t dt. What is this? Do you remember from let's say from 5.2? This is an exercise. I think you remember, Shabab, what we did, that I told you that the integral from 0 to b for x squared for x dx. We did this. It was b squared over 2. Do you remember that? So now if it is up to x, but it will not be suitable to have here the same variable. So just we will change this x to be t dt. Okay? So otherwise it will be the same. Now this will be, of course, according to that, this will be x squared over 2. So the integral from 0 to x, and we will see today by the fundamental theorem of calculus y, 0 up to x, the integral of g of t from 0 to x is x squared over 2. Now, I want you just to notice something. What will happen if I differentiate both sides? So take the derivative of this. What you will have here? You will have g prime at x equals what? What is the derivative of this, Shabab? If you differentiate this side, what you will have? What is the derivative? It is the half. This is a constant.
X.
The derivative of x squared, it is 2x. So this will be equals to x. So the derivative of x. So the g prime, which is the derivative of this integral. So it is the derivative of this. So now we have g prime of x, which is the derivative with respect to x. The derivative with respect to x, طبعا ddx of this integral. What is it? It is equals to x. Do you notice something? It is the same as the original function. So we obtain our function back. So this suggests indeed that the integral of this function from a to 0, it is f of x. You will get it back. Here we obtain our function back. F of t, it was t, now f of x equals x. And we will have this as a fundamental theorem of calculus part 1. So in this case, g prime is just the original function, the integrand function. طبعا, as I said, do you remember why? What does this mean? What does that mean? If you have two functions, ya shabab, g and f, and the derivative of g, it is f. So in this case, what we call g, we call f here is the derivative of g, but g, it is the antiderivative of f. So in that case, we will have what is called antiderivative. طبعا as g of x here, this g of x, it is a function. It is a function of x. If you put x equals to 1, this will be the integral from 0 to 1. What it will be? Just substitute here. What it will be? It will be 1 over 2. If you calculate it from 0 to 2, what is g of 2? It is from 0 to 2. Just substitute here because you have the value. So it will be also 2 squared over 2. It will be 4 over 2. It will be 2. The integral from 0 to 0, for sure, it will be 0. And just substitute over there if you want to know that it is 0. So according to that, ya shabab, we have the FTC. The FTC1 says, which is the fundamental theorem of calculus part 1, if you have f as a continuous function over closed interval a and b, then the function g defined by this. So you can just focus on this. Then the integral of f, this is f, then the integral of f from a to x, which is a function of x, so we will call it g of x. X here, it is between a and b, is also continuous. So this is good. If you have a function that is continuous over closed interval, then its integral over this interval is also continuous on the same interval. This is what this says. Not only that, we have another gift here. Not only continuous, and also it is differentiable on the open interval, which means that it is not necessarily to be differentiable at the end points. If it is, this is good, but no need. No, there is another gift also, an additional gift, that the derivative of this integral, the derivative of g is equals to what? So this is also saying that the integral from a to, so this is from a to x here. The integral from a to x, it is this one. It is also its derivative with respect to x, of course, is f of x. So I think I did summarize this. Yes, I did. So it was not necessary to write it. So here, what to summarize what is this theorem says, it says that if f is continuous, then the integral of f from a to x is also continuous and differentiable. And moreover, the derivative of the integral is equal to the integrand function, evaluated at the upper limit. Just notice what happened. We just put the upper limit inside the function. So we replace t by the upper limit. So in general, this is of course when we have this one as a variable of x. So now, ya shabab, we have answered the first question. What is the derivative of the integral of f from a to x with respect to x? It is f of x. It is the value of the function at the upper limit, when the upper limit is a variable. Any question about the fundamental theorem of calculus number 1? It is very important theorem. Okay, so this is just, if you have this, look what you have. Yes.
Doctor, in the bottom, we're considering a to be a constant, right?
A is a constant. Yes, it is. It is the left. The x is between a and b. X is any number between a and b, and e is the left end point.
No, I mean the integral of a to x. A is a constant, yes, and x is variable.
Yes, this is a. A is coming from here.
Okay.
A is less than x, of course. But it is not. What about if it is a shabab from x to a? What we will do?
Reverse it by putting minus.
It will be just the negative of the integral from a to x, and the negative will go out, so it will be the negative of the derivative. So it will be negative f of x. Good.
Doctor, is
yes.
it so basically the x? We can say, for example, the limits is 0 to 5, for example. So a to b is 0 to 5. The x could be 3 or 4, and then we replace it in the function, and that will be the derivative.
Any number, it will be any number, but it is here as a function. We are talking about the integral here as a function of x. Yes, after finding what is g of x, you can after that both f or gx to be any number, like what we did here in this way, if you remember.
Yes.
We bought x equals to 1, we bought x equals to 2, and so on. Now, by the way, Shabab, the proof of this theorem is interesting. I advise you to read it in your textbook if you are interested on the proof. I skipped the proof because I noticed that it is technical proof. It contains many mathematical concepts. That is, I think it is above the level of this course. But it is interesting for people. If you are interested in the proofs, please go and read the proof. Find the derivative of the function g of x, which is equals to the integral from 0 to x for square root of 1 plus t squared dt. So he is asking about the derivative of this function. So the question is, what is g prime of x? G prime of x, in this case, it is just what? It is the derivative with respect to x for this one. And how I know that it is the derivative with respect to x? Because what was the variable here? The variable is x. So it is just the integral of this one. Who can tell me what is it? Let me ask specific student, ya shabab. Let me ask Muhammad al-Hassan. Ya Muhammad, what do you think? What will be the result here? Just you need, ya Muhammad, to recall this.
To differentiate the function.
So it will be equals to what?
1 plus t square root 1 plus t square. We differentiate this function.
Differentiate this?
Yes.
No. No. This is not true, ya Muhammad. Just remember, ya Muhammad, let me write it for you. Let me write the fundamental theorem of calculus. The fundamental theorem of calculus says if you have integral from a to x for f of t dt, if you call it g of x, then the derivative is equals to f of x. This is exactly what is the fundamental theorem of calculus says, no?
Doctor, I don't know.
You don't know? I'm telling you, ya Muhammad, I'm telling you, if you have a function equals to the integral from a to x for f of t dt, then the derivative of this integral, the derivative of g, is equals to f, the integrand, the function that is here, equal at x, not at t. So this is equals to what, ya Muhammad? Ya Muhammad, this is of course. Oh, let me finish this. This is ya Muhammad, this is f of t. Just look at this, compare this with this, Muhammad.
We replace x, we replace t by x.
Just, it will be the square root of 1 plus x squared. Yes, f of x. Now you know it, ya Muhammad. Yes. Excellent. So this is just a direct application, Shabab. This is a direct application of the fundamental theorem of calculus part 1. Let me call it shortly FTC1. Okay, is it clear, Shabab? Now, if we have another function, by the way, this is a Fresnel function. It is well-known function. Fresnel function, which is the integral of sine of pi t squared t dt. Who can tell me what is s prime? What is s prime of x? Let me ask also Majid al-Madani. Ya Majid, what is s prime of x? What is the derivative of this function, ya Majid? Majid, are you with us? If you didn't respond, I will consider you absent, ya Majid.
Sorry, Doctor?
Majid? Yes.
Yes.
What is the derivative of this function?
By sine by 2 t square over 2.
So you are saying that it will be what? By
sine?
By sine?
By cosine, sorry.
By cosine. So what you are doing, yeah? By again, imagine you're not following us. By cosine?
by cosine by
By-
t square over 2.
over 2. This is not true. Majid, you are not following us. Yeah, Majid, let me repeat again. What is the fundamental theorem of calculus says? It says if you have integral from a to x for a function of t dt, then the derivative of this function is equals to the integrand just as it is. It is equals to f of x, just like that. Why it is so difficult, ya shabab, for you to realize that? Just it is the same as the function inside, but instead of t write x. So this will be just, this is our f. So it will be sine by, but instead of t, we will have x, because here we have the upper limit x over 2. This is the answer. You got it, ya Majid?
Doctor,
Yes.
When you differentiate, ya shabab, an integral, please, when you differentiate an integral, we are not differentiating what is inside. Be careful. So this is not, let me just make it clear. If you have a function here, whatever the function is, if you have a function here, this does not equals to the derivative of f at all. This is the derivative of g. This is the derivative of the function here. The derivative of the integral. This is equals to the value of the function at the upper limit, which is here x, if it is x, of course. Yes, who wanted to ask? Nawaf?
so doctor, basically we took what inside the integral of the function and substitute with the upper limit of the integral, and this is the differentiation. Is that right?
This is if you have the integral from a constant to x. We will see now if it is different from x. This is when you have an integral from a constant to x, Yes, you are right. Okay. So, ya shabab, understand it in words. It is better if you integrate from a to x for any function, for any continuous function, of course. Then this will be the value of the function of x if you differentiate this with respect to what? With respect to x. It should be clear. You need, ya shabab, to spend more time to understand this. The derivative of this integral with respect to x. Where is x? Here it is. Then it is equals to f of x.
Doctor,
Yes.
what if the upper limit and the lower limit are both variables?
This is what we are going to answer this question. We will answer it, ya Faris, in just 1 or 2 slides. Good
Okay.
question. I asked you this at the beginning, if you remember, if you were with us. Now we will have a case like now. This is what Faris asked about. What about if it is not x, if it is a function of x? What we can do? Remember that this is a function now. So we are differentiating now. We are differentiating. Let's call this one. Let's call it g of x, مثلا. So we are differentiating now g of x, but this is not g of x. It will be g of x to the power 4, because here it is a function of x to the power 4.
We do the chain
So
rule.
to differentiate with respect to x, what we will do?
We do the chain rule.
The chain rule. Yes, the idea is clear. طبعا we will do it for the first time with the chain rule. So we will call this. It is the same. If you have a function of x to the power 4, just both x to the power 4 equals to u. So this will be a function of u, and you need to ask yourself, what is du? Du will be 4x to the power 3 du dx. So what we will do now, just we will use a substitution. If you remember the chain rule. So here we have to be careful to use the chain rule in the conjunction with the fundamental theorem of calculus 1. Why we need here the chain rule? Do you remember it from math 101? Because we don't have x here. It is not a function of x, it is a function of another function. So if you put u equals to x to the power 4, so this, the derivative of x, the derivative with respect to x for this integral, it will be the derivative of x for this integral with respect to u. But now u is a function of x. Here is what is u. Now to differentiate, when you have a function of u, let's call it g because I don't want to confuse you. To differentiate it with respect to x, you need to differentiate it with respect first, with respect to u, then differentiate u with respect to x. This is the chain rule. So what we will do here, we will just keep this as it is, so it will be the same as the function, but we will multiply by the derivative of u. So it is the same as this. So the derivative of this will be the derivative of u with respect to this function of u with respect to u multiplied by the derivative of u. And this is exactly what the chain rule says. Let me remind you, Shabab, about the chain rule. The chain rule says if you have y as a function of u and u as a function of x, then dy dx equals to dy du dx. Do you remember that? So this is exactly what we did here. Also, you can write it like this: f prime at u, which is dy dx, it is the f prime with respect to x. Let me make it like this: d dx, to be more clear. It is equals to dy du, which is f prime of u, which is g in this case, equals to times du dx. Du dx is the derivative of x. So also you can think about it like this: the derivative of g of x. It is just the derivative at g of x times the derivative of the inner function. So now this will be equals to, that is the derivative of this. Forget about this now. What is the derivative of this according to the fundamental theorem of calculus? If you have here a variable and you are differentiating with the same variable, so just will be the inner function at the upper limit. Now du dx, what is du dx? It is so easy. What is du dx? It is 4x to the power 3. Do you still, ya Shabab, remember how to differentiate? Here it is. So here we applied the chain rule, and of course here the usual derivative, and here in this part we applied the fundamental theorem of calculus. So to summarize, what we conclude from this, if you notice what happens, you can do this every time. You can do that, no problem. But if you notice, it was easy from the beginning. Look what we did, ya Shabab. If you compare this with the beginning, look what we did. We just take secant t. Instead of t, we replace t by what? By x to the power 4. These we have replaced t by x to the power 4, and we multiplied by the derivative of this. Just simply like that. I prefer, ya Shabab, to write it. I don't know if he did or not. He didn't. I prefer to write this, ya Shabab, as 4x to the power 3 secant x to the power 4. Why? Because I want you to get confused that this is inside secant. It should be clear that it is outside secant. Yes, do you want to ask who? I think I heard someone wanted to ask.
I was just going to say that haven't we been doing this all the time with each one? But it's
no
just
need,
by one.
no need, yes. You can, why not? Yes, but after getting this, here we have, it is a theorem, but it is not mentioned in your book, by the way. I have added here because it is not in your book. Your book wants you to do this all the time, okay? For me, it's okay, you can do it, but also you can apply this directly. This, what you want, Nawaf, this says that if f is continuous, and also a function here, v is differentiable, you can find the derivative of it, then this integral, if it is x, ya Shabab, لو كانت هذه x, what we will have? It will be just f of x. Do you remember that? Now it is f, it will be f of v of x multiplied by the derivative of v. So this will be just like this.
Doctor?
Now it is a special case. The special case, when it is x, this will be x, and the derivative of x with respect to x will be 1. So it will be at the end f of x. Yes, Nawaf, what do you want?
دكتور في اللي سويناه احنا انه نزلنا الاكس اس 4 مكان التي وسوينا ديفرنشيشن لها وضربناها فيها. صح الكلام
Just
هذا؟
like that. Yes, just like that. Very easy. But as I said, يا شباب, please write the derivative in the front to avoid any confusion here. Okay. Now we have here what is called, if we let's generalize this طبعا. If you have here also a function. So in general, if you have a function in the lower limit and the function in the upper limit and you want to differentiate it, again, this is an exercise, by the way, in your textbook. So we have solved one exercise for you. Again, if the function is continuous and also u and v are differentiable functions, then this is the question that you didn't answer me at the beginning about it. Do you remember? Now, what this will be?
Is it
Also, yeah, Shabab, if you want to find the proof of this one, or what is it called? This is called, yeah, Shabab, the differentiation of integration, or the Leibniz rule. It is called the Leibniz rule for differentiating the integrals. So it is, in this case, it will be the value of the function here inside. Instead of t, you will write this, but you will multiply by the derivative of the upper limit minus the value of the function, the same function evaluated at the lower limit, multiplied, this is minus, multiplied by the derivative of the function that is in the lower limit. This will be the derivative. And I think now we answered your question. طبعا it was, يا شباب, a special case when this is a, when this is a constant. What is the derivative of any constant with respect to x?
0.
0. So this will be 0 and this will be 0 and it disappear. And we have the previous case. If this is x, this will be x and this will be 1. Log. So this is the general one, and this is an exercise in your book. I think we have answered now the question that is mentioned in exercise number 78 in your textbook. Again, Shabab, the proof is not difficult. It is just what they did, the integral from u to v, just they write it like from u to a constant, to any constant, plus the constant to v. And then they change this. It will be the integral from negative a to u, plus from a to v, and apply the previous theorem, apply this one, apply the one that we have here. You have it easily. Enjoy, ya Shabab, the beauty of mathematics and try to understand these issues deeply, not just to memorize them. No, try to feel them, to understand them. If it is not from the first time, just do more exercises and you will know you will feel the beauty of mathematics. This is an exercise for you to do. I think it is not difficult. What you will do now, Shabab? This is u of x. This is v of x. This is f of t. So it is a direct application for Leibniz rule. Okay. So this will be what, Shabab? Just this will be equals to, if you call it, you will bring this function here, but instead of t, what we will root here, Shabab?
x to the power 9.
So let me do it here for you. As I said, you can solve it this way. You can just put this equals to v, you can do it this way. So you can do it also directly. So it will be, just write the function that is here, t to the power 3 plus 1. Let me do it for you in two ways. First one, I will use it with substitutions. So let me call this f of t, and this one v of x. You can call it g of x if you don't like v, and this is u of x. So the integral here, just a direct application of this. What we will have here? This will be equals to what? F at v of x. So this is f. It will be f at v of x. What is v of x? It is x cubed multiplied by the derivative of v. What is the derivative of x cubed? 3x squared minus f at u here is 3x multiplied by the derivative of u. The derivative of u, what is the
3.
derivative of 3x? It is 3. So now what is our function? What is f? So instead of t, you will write x. So it will be x to the power 3, all to the power 3. Just we replace t by x cubed, plus 1, all to the power 10, multiplied by 3x squared, minus, here also instead of t, write 3x. So it will be 3x all to the power 3 plus 1 all to the power 10 multiplied by 3. That's it. We differentiate it. If you want to simplify more, what you can do? I think you can take a common factor or whatever, but it is okay to just, this is the answer. And of course, to simplify, this will be equals to x to the power 3 all to the power 3 will be x to the power 9. Here it is. As I said, it is better to write this at the beginning to avoid any confusion. And this 3x to the power 3, it will be 27x to the power 3. Is it clear, Shabab? So you can just do it directly. Just replace t by the upper and differentiate the upper, minus replace t by the lower and differentiate the lower. This is if you want to differentiate the integral. Please, ya Shabab, solve this all the exam question in 2 minutes. I will give you 2 minutes to solve this. Please try to solve it. Let me also launch a polling for you to answer this question. You have here a function of x. And you want to find, of course, its derivative at 1 and its value at 1. Let me ask Faris Turkey. Yeah, Faris, what is f at 1? I think this is not difficult. This is easy.
It's 0.
It is 0. Yes, thank you, Faris. It is 0, Shabab. F at 1. What is f at 1? Replace x by 1. So it will be 1 squared, 1 cubed, tan inverse t dt. This is a continuous function over from 1 to 1. So this is the integral from 1 to 1 for a continuous function. And this is, you know, that by the properties of the definite integral, this is 0. Thank you. So this is, ya Shabab, shortly, just we will say here that the integral is from 1 to 1 for tan inverse t dt. This is equals to 0. So Faris found the value of the function at 1. Who can tell me what will be the value of the function at 1? The derivative, the value of the derivative at 1. Continue, Shabab, solving. Muhammad Al-Assaf, if you have an answer, ya Muhammad Al-Assaf, for this question, what is f prime at 1?
I didn't solve it yet.
Continue, Muhammad. Continue.
Doctor, is it, shall I answer or?
Answer, if you have an answer, yes, please.
Is it 0? Also?
0, f prime at 1, it is also 0. This is what Saad says. So he said B. We will see, Saad, if your answer is correct or not. So who has another answer, Shabab? I'm asking Muhammad Al-Assaf. If you have an answer, ya Muhammad Al-Assaf or Abdul Salam Sihibani or Muhammad Mu'afa. Any one of these students, if you have an answer, ya Shabab, Muhammad Al-Assaf, Abdul Salam Sihibani, Muhammad Mu'afa. Do you have an answer for this question? Muhammad Al-Assaf, it is pi over
2.
Pi over 2, ya Muhammad. We will see if it is the right answer or not.
Doctor.
Abdul Salam Sihibani. Abdul Salam, what is your answer, Abdul Salam?
Yeah, C, I think.
You think or you are sure?
No, I solved it and I get pi over 4.
We will see, Abdul Salam, if it is correct or not. Muhammad Mu'afa?
I got minus negative pi over 4.
You are lucky. It is not in the choices. So it means that
Yes.
there's something that is not good about your answer. Okay. So let me, ya Shabab, show you. Let me end the polling and show you the results. So most of you choose the choice C. MashaAllah, 11 students with B and also 4 students with A. Okay, let's see what is the right answer. Let me just close this. Now, what is f prime at 1? First of all, if you wanted to find f prime at 1, you need to find first what is f prime at x. What is the derivative of this? So the f prime, ya shabab, will be the derivative of this integral. You will differentiate this integral. Now, what is the derivative of this integral according to the Leibniz rule that I just told you before? It will be the function, the integrand function, evaluated at the upper, multiplied by the derivative of the upper, multiplied by 3x squared. Am I right? Minus the same function, but evaluated this time at the lower, multiplied by the derivative of the lower. So this is equals to what? 3x squared tan inverse x cubed minus 2x tan inverse x squared. Now this is f prime at x. If you want to evaluate it at 1, it will be what? 3 times what? 1 squared, which is 1, tan inverse 1, minus 2 times 1, tan inverse 1 squared, which is 1. So this will be what? 3. What is tan inverse 1, ya shabab? Do you remember?
Pi over 1.
Pi over 4.
Over 4. So this will be 3 pi over 4 minus 2. What is tan inverse 1? It is pi over 4. So it will be 3 pi over 4 minus 2 pi over 4. It is pi over 4. So now here we want f at 1 plus f prime at 1. So it will be 0 plus pi over 4. It will be pi over 4. And the answer is C. Very easy question. Let's now continue. Now we need to introduce you to the second fundamental theorem of calculus. Now forget about what we did before, Shabab. This is part 1. Now we have part 2. In part 2, we will answer the question that I asked you at the beginning. What is, if you have the integral from a to b, f of x dx, what is it? This is equals what? I asked you this at the beginning. Also, I asked you another question. What is the, if you have a function, if you have an integral f of t dt from a to x, what is, and here you have the derivative. What is the integral of the derivative? Also, we will answer this question in part 2. So what does this theorem says? It says that if you have a continuous function over a closed interval, then its integral from a to b for f of x equals to f capital of b at b minus f capital at a. What is f capital? This f capital. F capital here.
Antiderivative.
Antiderivative. It is the antiderivative of f. What do you remember what we mean by the antiderivative? It is the function that its derivative equals to f small. So if you have a function f small, its antiderivative f capital, what is it? It is the function that if you differentiate, you will get f. Ya Shabab, the antiderivative you have studied at the end of the course Math 101. You know, if you have a function, you know how to find the derivative. This is the derivative. This is clear. Not, this is Math 101. Now the question, if you have the function, and the question is, this is equals to the derivative of which function? This function that you will look for, it is called the antiderivative. Okay, so it is the opposite question. Not what is the derivative, what is the antiderivative? What is the function that if we differentiate, we will get our function back? So what does this say? Yani f of x, we can remove f of x, ya shabab, and write what? Instead of f small of x, we can write f capital. So this theorem says that if you integrate the derivative of a function f capital, then the integral will be f capital, the original function, at b, at the upper limit, minus the antiderivative at the lower limit, the same function. So in other words, if you use this, the integral from a to b for g prime of x, dx, this equals to g at b minus g at a. And this is amazing, ya shabab. X here, it is between a and b. But what is the most important 2 points that will calculate the integral? They are just the last limits, the upper limit and the lower limit. The point at the end, the left end point and the right end point. This will, of course, summarize the whole history of the process. So, what you need to understand, Shabab, from part 2 of the derivative, that if you, we will use this notation, Shabab, for short. If f at b minus f at a, it is just can be written this way, or also this way. We can write it also, I think they are using, yes, this vertical line also this way. Usually we will use this one. So we can now write this theorem in another way. We can say that this is equals to the antiderivative at x from a to b. From a to b. This one means this. I think I have mentioned it here for you. Is it clear, Shabab? Did you understand the second part? So this is just saying that the integral of f of x is just the antiderivative. I think we should mention it here. So part 2 of the fundamental theorem of calculus says or states that if you know an antiderivative, we can know the general antiderivative, just add a constant, and you will know the more general antiderivative. Then to evaluate this integral, simply subtract the values of f at the end points of the interval. As an example, you just to know that this is not for fun, it is for real, that if you remember the velocity is the derivative of the position function. So if we have an object that moves in the positive direction, so here we have v of t is always positive, then if the velocity always is positive, we have the integral of the velocity to be the position function at the end minus the position function at the beginning. This will give you the distance traveled. We will stop here, ya Shabab, and we will continue, inshallah, next class on Monday. See you.